You ever stop and wonder what connects, say, a rusty nail, the thoughts firing in your brain, and the medicine that can save a life? Well, the answer to all of that is chemistry. It's not just some subject you learn in school. It's literally the science that explains what everything is made of and how it all works. And we're about to break down what that really means.
I love this quote from Ronald Hoffman because it just hits the nail on the head. Chemistry is creative. It's all about understanding the most basic building blocks of our universe and then using that knowledge to build, to change, and to create this incredible, infinite variety of new things.
But this mission to understand and mess with the world on a molecular level, it is not new. This is an ancient human quest, a story of curiosity that goes back thousands and thousands of years, long before we had fancy modern labs.
Way back in ancient India, for instance, they had Rasayan Shastra, which covered everything from making metals to medicine. And then, of course, you had the alchemists in the Middle Ages, famously trying to turn lead into gold with a philosopher's stone. Now, they didn't quite get there, but all their experimenting actually laid the foundation for modern chemistry, which really started coming into its own in the 1700s.
Okay, so to really get chemistry, we've got to start with its main character, matter. Let's start our journey by zooming in and taking a good look at the very stuff that makes up, well, everything.
So what even is matter? The definition is actually beautifully simple. It's just anything that has mass and takes up space. Seriously, look around you right now. The book on your table, the water in your glass, the air you're breathing, even you, it's all matter. Now, this matter usually shows up in one of three states, and the big difference between them is just how their tiny particles are behaving. In a solid, those particles are jammed together, super tight. In a liquid, they're still pretty close, but they can kind of slide past each other. That's why liquid flows, right? And in a gas, the particles are super far apart, just zipping all over the place. It's all about how they're arranged and how much energy they have. Okay, so we've got all this stuff, all this matter. How in the world do chemists even begin to organize it all? Well, they start with one big fundamental split, sorting everything into two main buckets.
On one side, you have mixtures. In a mixture, the recipe can change, and you can pull the different parts out using physical means, like picking the nuts out of a trail mix. But on the other side, you have pure substances. Their composition is totally fixed, it never changes, and you can't separate their parts without a full-blown chemical reaction.
Let's look a little closer at mixtures. There's the homogeneous kind, like sugar dissolved in water, where everything is blended so perfectly you can't see the individual bits. It's uniform all the way through. And then there's the heterogeneous kind, like just mixing salt and sugar grains together. The composition isn't uniform at all, and you can totally see the different components.
All right, now let's set mixtures aside for a moment and dive way, way deeper into those pure substances. This is where we're going to find the absolute ultimate building blocks of our entire world.
So, the simplest kind of pure substance is called an element. Think of it as something made of only one single type of atom. That's it. The copper in a penny, the silver in a necklace, the oxygen we're breathing, those are all elements. You can't break them down into anything simpler through chemistry.
So what happens when different elements decide to chemically link up? Well, then you get a compound. This is also a pure substance, but it's made when atoms from two or more different elements join together in a really specific fixed ratio. Water, H2O, is the perfect example. It's always two hydrogen atoms for every one oxygen atom.
And this right here, this is where the real magic of chemistry happens. Get this. You take hydrogen, which is a gas that burns, and you mix it with oxygen, a gas that fire needs to burn. When they chemically bond to make the compound we call water, you get a brand new substance, a liquid, that puts fires out. The properties of a compound can be completely, radically different from the elements that make it up. It's just incredible. Okay, so we've zoomed all the way down to the atoms. Now let's pull all the way back out to see the big picture and why understanding all of this is so unbelievably important for our world. The truth is, these basic principles of chemistry are working all around us, all the time. They are absolutely essential for making life-saving drugs, for manufacturing the fertilizers that help feed billions of people, and for creating the materials that our entire modern world is built on. Chemists are even on the front lines, fighting environmental problems by designing safer chemicals. I mean, from the farm to the pharmacy, chemistry is at the heart of human progress.
And that brings us right back to the beginning. We've got this limited palette, right? Just over 100 elements to play with. But from those few ingredients, as Roald Hoffman said, we can build a truly infinite variety of molecules. That's the power and the promise of chemistry. It's a field of endless creation, always shaping our future. The only question left is, what will we create next?